right, guys, here we go with our Chapter 3 mid-chapter test review. Start with question number 1. If you have questions along the way, you just raise your hand and I will stop. Number 1, determine whether the relationship between the two quantities described in the table is linear. I'm going to underline a few things that I think are important here. They want us to, there we go, determine whether the relationship between the two quantities is linear. And then, if so, they want us to determine the constant rate of change. So this is what we're looking for. If it's not, then we have to explain our reasoning for why it isn't. All right, so anybody know how we can find out if there is a constant rate of change?
On each side.
That's right. On each side, we're going to find out what's the rate of change, or what's the change happening here? Plus 25, okay? Plus 25, plus 25. So would you say that's constant?
Yes.
Yes. Okay, so then on this side, do we also have a constant rate at the same time? Yes, we do. It's plus 3, plus 3. So while we have a constant change on this side, we also have a constant change on this side. This is our y, and these are our x values, right? So how do I find the constant rate of change? Change in y over change in x. So the change in y is 25. Put that over the change in x, which is 3. And if you don't know what that is, you have those wonderful little tools on your desks called calculators. Punch it in and see what you get.
8.33.
So 8.3 repeating. Another way to write 8.3 repeating, we could either write it with the repeater bar, or we could write 8 and what? What fraction? 1/3. Okay, so it says determine whether the relationship is linear. Is it? Yes. And why? There is a constant rate of change. And what is it? Because that was the other thing they asked us for. What's the constant rate of change? 8.3 repeating, or 8 1/3. Good. Okay, number 2. They're asking us for 2 and 3 to determine the slope of the line that passes through each pair of points. So we have a formula that we can use, and it looks like this. M is equal to y2 minus y1 over x2 minus x1. And I'm just going to go ahead and identify that this is my x1, this is my y1, this is my x2, and this is my y2 right now. And I'll do the same for this one. x1, y1, x2, y2. Now all I have to do is take those numbers and plug them into our formula and solve. Okay, so m is equal to y2 minus y1 is going to look like what? M is equal to what? A negative 3 minus 4 over 3 minus 0. Good. Okay, now, if you get hung up on adding and subtracting positive and negative integers together, use your calculator. Punch in negative 3 minus 4 and tell me what you get. You get negative 7. Okay, so we have negative 7, and 3 minus 0 is what? 3. Now, when we're talking about slope, is it okay for us to leave this like this? Yes, it is. Because why? What's the purpose of leaving it like this when we're talking about slope? It's easier for us to find what, Joanna? The rise over the run. Okay, good. All right, let's go ahead and plug this one in. I'm going to go ahead and erase this formula because now we know what it is. So help me plug in the values so we can solve this one. We have m is equal to what, guys? Negative 3 minus negative 7, and all of that is over what? 2 minus a negative 6. Now, here is where it gets a little bit tricky because we have a minus a negative. We can add a line, and then that lets us change that sign. We cannot change the sign without adding that line. So we can do the same thing down here. Now we have negative 3 plus 7. What's negative 3 plus 7?
4.
Positive 4. And then 2 plus 6 is positive 8. Now we have 4 over 8, which reduces down to what? 1 half. Any questions about 1, 2, or 3? All right. There's a little bit of a typo here. This should say soda. All right. It says a supermarket sells 2 bottles of soda. 2 bottles of soda for $1.80. The cost of soda, Y, varies directly with the number of, this should also say bottles, bottles, X. They want us to write and solve a direct variation equation to determine the cost of 5 bottles of soda. I am boxing this up because this is what they are looking for. I feel like it's important. What's the first thing that we should do in order to figure this out? Before we can go all the way to the end and write a direct variation equation, what? Well, before we can do that, we have to find out what. If we know it costs $1.80 for 2 bottles, we want to find
out how much it costs per one.
That's right. We want to find out how much it costs for just 1 bottle. So how do we do that? Divide what by what? Yes. $1.80 divided by 2 tells us that it's what? 90 cents. 90 cents for just 1 bottle, right? All right. Good. Everybody good so far? Now we found that. What does our direct variation equation look like then? Right. It's y equals kx. But then what are we plugging in for k? What did we find over here? Right, what does the 90 cents represent? It's our unit rate, but it's also our slope. And it's also what? Constant rate of change, constant of variation. So what goes over here? Y is equal to what? 0.90 times x. There's our direct variation equation. Now, in order for me to find out how much it costs for 5 bottles, what do? Plug it in, right? And multiply 0.90 times 5. And what do you get?
You get 4.
We're talking about money. $4.50. Any questions? All right, 5 and 6. They're asking us to determine the slope of each line. We're going to use 2 different methods here. We're going to use one for one and one for the other. We're going to have to look at them to figure out which one we want to use for each. Take a look at number 5. What do you suggest we use to find the slope for this one based on the fact that we have a graph? I heard somebody whisper, rise over run. I agree with you. All right, so let's start at C. Can somebody else tell me what kind of slope is this? Positive, negative? It's negative. How can we tell?
Because C is going down.
Because it goes down from left to right, so it's negative. So that way I know my answer will be negative. All right, so let's start at C, and we're going to work our way down to D. So let's count it out. Down 1, 2, 3, 4, 5, 6. That's negative 6. And we're going to run over how many? 2. Run over 2. And so I have a negative 6 over a positive 2, and I can even reduce that further by using what? Division, right? So negative 6 divided by 2 gives us what? Negative 3. So our slope of this line is negative what should we use on this side? If we used rise over run over here, what should we use over here? We've got a whole table full of points we could use.
The thing we did for number 1.
Yeah. So Chelsea is saying, let's use this. y2 minus y1 over x2 minus x1. What formula is this? Slope formula. Yeah, so we're going to call this our point 1. We'll call this point 2. I'm going to go ahead and label it. This is x1, this is x2, this is y1, this is y2. All we have to do is plug them in now. What's it going to look like? M is equal to what over what? Can't hear you. 5 minus 10 over 2 minus 0. 5 minus 10 gives us what? What kind of 5? Negative 5. 2 minus 0 gives us. Is it okay for us to leave it like this for slope? Yes. Why? Because it helps us see the rise over the run. Okay.